All right, so very good morning, everyone. Uh, a very happy new year to all of you. I had somehow thought that most of you are on campus, but all right. So let's get on with the class. Now, um, today, what we are going to do is you will be looking at a case study that involves design of machine elements for for a permanent magnet alternator design. So the overall objective of today's class is to show you as to uh, what is it that you are going to do um, based on what you will be learning in this particular course, and what does machine design as such entail. Okay, so the basic question that you will be trying to answer today is, okay, what is machine design? Now, to understand this particular sorry, just a second. To understand this particular aspect, so i'll be covering um, I'll be covering design and analysis of a permanent magnet alternator. Okay, so what is an alternator? What do you understand by an alternator? Are you able to hear me?
Yes, sir.
Yeah. So what do you understand by an alternator?
Sir, that something that alternates the direction, changes the direction with the equal magnitude.
Um in some simpler term, it's basically an electrical generator. Okay, so motor converts electrical power to mechanical power. An alternator converts the mechanical power input to electrical power output. Okay, so all right. Now, in this particular case study, I'll be talking about. So, when we say machine elements, what are we referring to? So, when you say machine elements, you are basically referring to components like this. Okay, so in most of the machine design, you are going to encounter shafts, keys which connect, let us say, something like gears and pulleys to shafts, bearings on which the shafts are mounted and which allow the shafts to rotate freely, belt pulley systems or chain sprocket or gears, springs, and then some structural components. Components need to be joined together, so they can be joined using either welds, adhesives, bolts, rivets, or instead of ball bearings, you can have bushings to support rotating shafts. Okay, brackets are again another kind of a structural component. So any machine that you consider for analysis is going to consist of a uh, bunch of things, and what is the primary purpose, do you think, of doing any sort of analysis, particularly this design analysis?
Sir, we to support the structure and see the strength it is required. It's working. The we create a model and the model is working or not, so that we can implement in real life.
So, see, anytime you have a certain requirement, okay. So, for example, let us say you are talking about design of a power jack, which needs to be used for lifting a car whenever there is a puncture. Okay, and then the tire needs to be removed and replaced with the stepney. So, when you have a requirement like this, so some specifications are provided to you. Okay, so what would be a typical specification? So for the power jack, one very important specification is the weight it will be able to lift. Okay, so we say, okay, it's a 1 ton rated power jack, it's a 2 ton rated power jack. That's one aspect. Okay, as to what is the weight it will be able to lift. And then another very important input is uh, in the case of a power jack, we need to be able to basically lift the car using the force exerted by our hand. Okay, so like a comfortable level force that you can exert would be somewhere around 15 kg. Okay, so using a 15 kg force, you need, let us say, to lift about 1 ton force. Okay, so you need the system to provide you some mechanical advantage. So anytime someone comes to you with a certain requirement for a certain machine design, the first thing that you do is try to come up with a design which will handle the kinematics correctly. Okay, so whatever is the mechanical advantage you require, your design must be able to provide that. So you start with kinematics, then you get to the kinetics, which is what is the input force, what's the output force, and you draw free body diagrams for each of the members, and you work out what are the forces that they are subjected to. This is the first stage of design. And then after that, you propose a certain machine, means you propose certain designs or drawings for each of your components. And once you get to that stage, okay, now you have a design where the kinematics works out okay, you know what are the forces acting on each of the members. Then beyond this point, whatever you do, it comes under analysis of machine elements. Okay, now so what are you worried about? So beyond this point, so let's say you have proposed some drawings which provide you the desired kinematics and kinetics. Why do any further analysis beyond this point?
To prevent failure.
Very good. So you do not, you need each of your machine elements to provide you with a certain life. So if you have a bearing, for example, okay, uh, I'm talking about coming up with a machine component which will be employed on trains. And in the case of in in this application, so for the case of bearings, okay, life is specified in terms of kilometers traversed. Okay, so for example, uh, in the application, Indian Railways may say that means I would need the bearings to survive at least for 3 million kilometers. Okay, 3 million running kilometers. So uh, so you need your machine components to give you a certain life, and whatever analysis you do is to ensure that they do not fail before that. What is the cost of failure? So means in what all ways does failure hurt you?
Human life.
So that's the ultimate thing, that if you have loss of life, that is the worst that can happen. Let us say there is a belt failure in this particular design. It may not really result in an accident, but how else will it cost you?
The work, the quality of work and the time the work has to be delivered to a particular person or supplier. The work will get hampered.
So you are going to have downtime. Okay, so whenever you are talking about industrial settings, okay, you cannot afford to have downtime for your system. Okay, so more the time for which let us say the train has to be stopped in order to change a component, that's a huge inconvenience. Or for that matter, let us say the train has to go to the workshop so that certain components can be removed and some other replacements can be put, again that's a huge loss of revenue for the loss of revenue for the company. Now, in addition to downtime, you also have replacement costs. Okay, so in any case, so you do not want failures, and that's one of the primary reasons why you do why you do design analysis. So let's get in details about this particular problem. First, some background. Okay, now all of you have traveled in trains, right? And most of you have would have traveled in passenger trains. There are different kinds of passenger trains. Okay, you have the intercities, you have the local trains, metro trains. Okay, now let us talk about the intercity trains, which most of you use to, let us say, come from your home to IIT Kharagpur. Now, you must have heard the word called locomotive. Okay, um, you must have heard the word locomotive when it comes to trains. So, what do you understand by a locomotive? What do you understand by a locomotive? It's based.
Something which has the motive of uh, locomotion.
No.
Engine, engine compartment.
Yeah, so it's basically a unit which can generate, means which can generate the traction. Okay, which can generate the force which is required to pull the entire train. Okay, so all right, so there are what are the different kinds of locomotives which you are familiar with?
Diesel, electric,
So
biofuel.
so broadly speaking, in Indian Railways, you have electric and diesel. Okay. Now, until recently, both were in similar numbers, but right now they're trying to switch to electric pretty much in all the cases. Now, okay. So what happens is, in the case of trains, so please pay attention to the picture on the left. Okay, so pay attention to this particular picture. Now, what do you see? You see some overhead cables, right? So you have some high tension. You have some high tension overhead lines. Okay, and then you can see something called a pantograph. Pantograph. So basically, the pantograph helps you draw draw the current from the overhead cable into the train. Now, the overhead lines, what do you think these are? These are alternating currents or AC or DC lines?
AC.
This
AC.
is an AC line. Okay. So, roughly speaking, this is what happens in the case of electric locomotives. Let me zoom this up. So, what happens is the power initially comes from the overhead line through the pantograph. Okay, it comes to the main transformer. So in the main transformer, you reduce the voltage of the you reduce the voltage and increase the current, and then it is sent to a rectifier. So what will the rectifier do? The rectifier takes AC and pumps out DC. Okay. Now this DC power is then sent to, sorry, is then sent to two different inverters. Okay, the main inverter, it takes in the DC current, and then it provides the AC current which is needed to run motors. Okay, there is one motor for every axle. For every wheel set, there is one motor which is rotating the wheel set, and the second inverter is used to basically get the power which is needed to drive the auxiliary units. So what are the different auxiliary units? So fine, so you have some motors, cooling, compressors, okay, compressors and so on. So broadly speaking, this is what happens. The important point that you need to understand is that mm, you have motors mount, you have one motor per wheel set in locomotive. Okay, so this is what you have. And if you now go to the other coaches, okay, so what do you see? These other coaches, okay, whether these are AC or non-AC, okay, so what can you tell about these particular coaches? Are they drawing any power from the overhead lines? Are they? No.
No.
Okay, so
No.
these are not powered externally. Okay, now you have all traveled in trains, right? Do you see any electrical cables that are running from the locomotive to each of these coaches? Do you see?
Yes, sir.
No, sir.
Okay, you do not have anything. Okay, electrical cables, if they are there, okay, they would be pretty ugly, they would be very thick, and they need to be heavily protected. Okay, otherwise, well, you can have shock and then fatalities from shocks. Okay, so there are no electric cables running from locomotive to coaches. Okay, now in most of the cases there is only one electric locomotive which is pulling the passenger train, but sometimes, particularly when you are dealing with Rajdhani trains and they want to provide higher tractive force, then they have two locomotives, one in the front, one in the back, uh, one in the front and one in the back. Now if there is no electric cable which is running from the locomotive to the coaches, then how are the coaches powered? Because we all know, right, that you have electrical points within the coaches, and if it is a AC coach, then the air conditioning unit also needs to be running. And all of you have must have seen that as soon as you enter the AC coach, okay, on one side you have these panel boxes which have controllers for the air conditioning units. So if the electric cables are not running from the locomotive to the coaches, and if the coaches themselves are not really drawing any power from the overhead lines, you can see that there is no pantograph for the there are no pantographs for the coaches. So then how are the coaches powered?
So maybe through the rail lines down.
No, you have all seen the track. You must have walked on the track. Many of you must have crossed the track to go from one platform to another platform. Do you think anybody would allow you to cross the track if there are some high voltage lines on the floor?
They have batteries.
Huh? Batteries will not
Batteries.
last
Basically,
forever. Batteries need to be charged.
basically,
So there are
basically
some
when
metal plates between the bogies. They
No,
might be some.
those are for basically applying the tractive force. Means
Sir, in the new coaches, there are
so the
batteries
power is
beneath
generated
the
from the
coach.
motion of coaches.
But
Motion of coaches convert mechanical energy to electrical energy.
so
Yes.
what they do in order to um, what they do in order to power the coaches. So I'm going to talk about AC coaches in particular because they require they have a much higher power requirement. So the way it works is like this: that the locomotive pulls the coaches along the track. Okay, now depending on the number of coaches, depending on the number of locomotives, that will decide the amount of tractive force and the acceleration, maximum acceleration that you can get. Okay, that's what maximum acceleration that you can get. But nonetheless, by applying the tractive force for a long period of time, they can achieve reasonably high speeds. Okay, now while the train is moving, okay, by the way, if you look at coaches, okay, so every coach has got, like, so one coach has two bogies. Okay, so and each bogie has two wheel sets. Okay, so while the train is moving, what you do is you use the motion of each of the wheel set to rotate a alternator. Okay, to rotate a alternator. So, and in order to power the coaches, for AC coaches there are two alternators per coach. Okay, earlier the alternators used to have a power rating of 25 kilowatts, but now they want to move to a slightly higher power rating of 30 kilowatt. Okay, so right, so they use alternators to basically convert the coach motion, or use the rotation of the wheels to basically rotate the alternator shafts, and in turn through which you want to generate electric power. Now, just to give you a little more details to make it more interesting for you. Now, whenever you're talking about generators, they would not be able to achieve, means you would not be able to get power out of them in any reasonable manner until the shaft rotates at a certain speed. So, so in the design that we will be talking about, um, so the full output is achieved at the alternator rotational speed of 600 rpm, which corresponds to a train speed of 36 kilometers per hour for 36 kilometers per hour for new wheel sets. Okay, and from the alternator, what you get is AC power output that is rectified. So that is rectified. So whenever you convert AC to DC, the power electronics used is called a rectifier. Okay, so it is rectified to get a DC power output, and then that DC power is stored in a battery bank. Okay, so currently Indian Railways is using lead acid batteries, and they use a battery bank of 110 volts nominal voltage, and 1100 ampere hour energy capacity. Okay, so now you see, so the electrical sockets that you have in the coaches. Okay, what is the voltage rating? So this is the voltage rating normally of the sockets of electrical sockets. Okay, what is the voltage rating of the electrical sockets in your house?
volts. 220 volts.
It's 240 volts. Okay, so so home line means homes have 240 volts AC. Okay, now so why don't your adapters or something burn when you plug your like phone adapter or laptop adapter into the sockets in trains? There is a big voltage difference, right, between what you have at your home and what you have in trains. So why doesn't something dramatic happen? So if you look at any adapter that you have, So right now itself, you can go and take a look at the power adapter that you have. You will see that the voltage rating that they provide, okay, is normally means the input voltage can lie within a wide band. So for my MacBook, I'm looking at it right now. So for my MacBook, the input voltage to the input voltage can lie between 100 to 240 volts. Okay, so the adapters have been designed to work in a wide range of input voltages. That is the reason that it's okay for you to use this 100 volts line in the trains and 240 volts AC line in your houses. Okay, and then from the battery bank you use these inverters to get AC power to run the electrical units, including air conditioning in the coach. Okay, so this is how the coaches are powered. Now let us come to the alternator itself. Okay, so um, so this is the wheel set. Okay, I'm calling it a wheel set. Okay, any ideas why am I calling it a wheel set instead of basically referring to this as some axle and wheels?
Sir, because both wheels have same RPM.
Because wheels are rigidly mounted on axle. In the case of trains, you cannot rotate you cannot rotate the left and the right wheels at different RPMs. Okay, they have to be rotating at identical RPMs, because when you're mounting the wheel onto the axle, you use a interference fit, and it takes an extremely large force to basically move the wheel with respect to the axle. For this particular reason, in the case of trains, we refer to this wheel and axle as a wheel set. Okay, so when the locomotive is pulling the coaches along, the wheel sets are rotating. So now what you do, the employed kinematics is like this. So kinematics refers to the study of motion in the problem. Okay, so how exactly is the motion taking place? So as the wheel set rotates, there are couple of pulleys. Okay, so these two things over here, the green colored things, these are the pulleys. These are the pulleys. Now, so using a belt pulley system. So what are the typical power transmission systems or mechanisms which are employed? So belt pulley system is one. So in this example, belt pulley system is being used. So the green colored things are the pulleys. So these are the belts. Okay, these are the belts. So how many belts are there in this particular example?
2 belts.
Come on, these are separate ones.
6 inside.
6 on each side. Okay, so you have 6 on each side. So belt pulley system is one. What are the other mechanisms for transmitting the power from, let us say, one shaft to another shaft?
Sir, gears.
So fine. So gears is one way. So in the case of cars or trucks or any other heavy duty vehicle, you normally use gears. Okay, for the main power transmission system, that is to transmit the power from the engine to the wheels, you use gears. Okay, fine. So gears, belt pulleys. What else? In the case of bicycles, how are you transmitting the power from the pedal to the wheel?
Using to chain and like shaft belts
Chain and
and
sprocket. Okay, so you normally employ one of these three mechanisms. Okay, so you use either belt pulley gears or chain and sprocket. Okay, so these are the three ways which you normally use to transmit the power from one shaft to another shaft. Okay, so when do you think you would go with belt pulley system or chain and sprocket system as opposed to gears?
When the shafts are not very near, they are far away.
That's a very good answer. So one of the important factors for considering belt pulley and chain sprocket system over gears is the distance between the shafts. So whenever power transmission needs to take place in a very small region in space, you go with gears. Whenever power transmission needs to take place over long distances, then the belt pulley or the chain and sprocket systems are preferred. Now in an application like this, um, what do you think is the advantage of going with belt pulley system over chain and sprocket?
So chain and sprocket require lubrication frequently.
So chain and sprocket systems require lubrication and much more maintenance as compared to the belt pulley systems. Okay, so they're more rugged, more robust. So that is the reason that fine. So in this application, they have gone with this belt pulley system. So using the belt pulley system, what you do is you use the rotation of the wheel set in order to rotate the shaft of the alternator. Okay, or let me call this in abbreviated manner PMA, permanent magnet alternator. Okay, now what do you see over here? The pulley which is mounted on the wheel set is much bigger as compared to the pulley which is mounted on the alternator. So what will this do? It will increase the RPM of the alternator. Okay, so whenever you're dealing with motors or generators, their RPM is typically much higher as compared to that of the as uh, compared to that of the end unit. So in this case, end unit is the wheel set. So wheel set RPM is much much smaller as compared to RPM of the alternator. Okay, now there are a few interesting design aspects over here. So first thing is you can see some tension rods. Okay, so these are some tension rods. What do you think is their purpose? The answer is there in the name itself.
You neutralize the tension in the belts.
Not to neutralize it, to cause
So
the tension in the belts. Okay,
to maintain the tension in the
what is it?
maintain the tension in belt.
Yeah, it is to generate the tension in the belts. Okay, so whenever you want to transmit power using belt pulley systems, you need two things. You need friction at the interface between the belt and the pulley, and you need tension in the belts. If these are not there in sufficient amounts, you will not be able to transmit the required amount of power. Okay, so in this case, generating required tension is very important, and you use tension rods for that. And because you need to move the distance between the shafts using these tension rods, you cannot rigidly mount the alternator on some structure. So it is means you use a swing arm arrangement. Okay, so here you can see within the design. Okay, so you have a swing arm arrangement. This is a very popular arrangement. Okay, so okay, anyhow, so you have a bracket, there is a pin, and the entire permanent magnet alternator is basically swinging about this particular pin. Okay, so and you use this tension rod to basically allow that swinging motion and generate the desired tension within the belts. Okay, so fine. Externally, this is what we can see, and the structure that you see is a part of the bogie frame. Okay, so all the
Sir,
yeah.
why can't we have rigid attachment? Like, why do we need a swing arm arrangement?
So let us say you have a rigid attachment. Okay, then how do you generate the tension in the belts?
Okay, sir. All right.
Okay,
Got
so
it.
the wheel sets are rigidly fixed with respect to the bogie, nearly rigidly fixed with respect to the bogie. If PMA is also rigidly fixed, then you cannot adjust the gap between the two, and you cannot generate the desired tension in the belts. That is one reason. There is another reason that whenever you have jerks within the system, okay, meaning when you have some vertical acceleration, longitudinal acceleration due to some discontinuities on the track, if you do not allow this swinging motion, then a very large inertial force will get generated on the means on this PMA, and then the brackets may also fail. Okay, so it also helps with maintaining the structural integrity of the system. Okay, now let us look at the components of the permanent magnet alternator. Okay, so uh, so where do we start? So let us start with the pulley part. Okay, so I have already told you that there are 6 belts. 1, 2, 3, 4, 5, 6. Okay, so there are 6 belts which are transmitting the power from the wheel set to the alternator. Now, how is the power being transmitted? So, how is the pulley rotation being converted to shaft rotation?
Sir, by friction.
Okay, I'll come to that. So, this is typically made from cast iron. Okay, pulleys are typically made from cast iron. They are casted. So there are 2 ways through which power is transmitted from the pulleys to the shafts. Does anyone else like to add to that answer? Fine. So okay, so mode of power transmission. So one is through friction. Okay, so friction, and there is something else. And you also use key. Okay, friction and keys are used to transmit power from pulleys to PMA shaft. Okay, so what do you do to means if the shaft is purely cylindrical, would you be able to transmit the power through friction?
No, sir.
If you have an interference fit, yes, you can. But if you do not want to have an interference fit, then you cannot transmit the power. Okay, so think of means let us say you have your pen or pencil or something like that. You put a ring around that particular pen or pencil. You can easily rotate the ring without rotating the pen or pencil if there is clearance between the two. Okay, but if you want to have a interference, okay, meaning the pin okay, so here what you do is, in order to do the power transmission, you use a tapered surface. Okay, so here you use a tapered surface. Okay, you use a tapered surface, and then how does the tapered surface help you? See, here you can see the nut, right? So what you do is On the shaft, you have a threading over here. Okay, so you have a threading, and then you use a nut. As you tighten the nut, okay, along with a washer, as you tighten the nut, what is happening? The pulley is getting pressed onto the pulley is getting pressed onto the shaft, and then what will happen at the interface on the tapered surface as you tighten the nut? This is similar to what happens for the drill bit or the milling tool when they are inserted into the spindle. Anyhow, pressure is generated at the interface, which helps power transmission through friction. Okay, so already what all geometric features did you encounter? So by this stage itself, you have seen a tapered, a thread cutting feature on the shaft. Then there is a slot which has been cut for inserting the key. There is a tapered surface. Okay, and then after that, what do you have? So fine. So using this mechanism, the pulley is used to rotate the PMA shaft. Okay. Now the PMA shaft needs to rotate freely with respect to the body of the PMA, right? So this is the PMA body. So this and this are PMA body. Now the shaft needs to rotate freely with respect to the PMA body. So what do you need in between the two? You need a bearing. Okay, so bearing separates stationary components from rotating components. So bearings are a means these are something that will be there in all the machines that you are going to encounter. Okay, now why would you use a bearing instead of, let us say, plain bushing? Why can't I have a simple hole within the structure and then just place the shaft within the hole?
Bearing reduces friction.
So bearings offer a lot of different advantages. Okay, so first thing is that they reduce the play within the system. What do you understand by play? You must have heard the word radial play, axial play. Have you heard these words before?
No, sir.
Yes,
Play
sir. Sir,
refers.
motion generated due to structural imperfections.
No, not very correct answer.
So like scope for movement.
Play refers to the free movement, uh, that is available within the system. So for example, if I can move the shaft freely by a certain amount with respect to the body, the PMA has been removed for maintenance, I have held the body fixed, and I am now moving the shaft. Okay, so by whatever amount I can move the shaft in the radial direction freely, okay, that is called radial play. Okay, by whatever amount I can move it freely in the axial direction, that's called axial play. Okay, now in the case of bushing, um, we will have means some radial play. What will give, means what causes radial play or axial play? Gaps.
Sir,
Gaps
some
within the components cause the play. So if you want to have a clearance fit, then definitely there must be a gap between the shaft and the bushing inner diameter. Okay, that gap allows you to have a free movement. So whenever there are clearances, there will be play within the system, and play is bad for a multiple variety of reasons. In any case, so bearings can make sure that there is very little play within the there is very little free movement, and yet you can rotate the shaft freely with very little friction, so roller bearings are typically used in majority of the applications because they allow free movement at variety of rpms. So you can rotate the shaft at low rpm or high rpm, it won't matter. The roller bearing will support the shaft. So for what kind of bearings rpm becomes very important? So whenever you employ hydrodynamic lubrication, oh, okay, I'm not sure if have you heard the word before?
Yes, sir.
Yeah, so whenever you employ hydrodynamic lubrication, RPM becomes very important, and only above a certain critical RPM, the hydrodynamic lubrication would work. Okay, nonetheless, so in this case, they make use of bearings. So the bearing that you have over here, this is called a cylindrical bearing because the roller element here is a plain cylinder. Okay, so fine. So you have the tapered surface, okay, and then there is a small step within the shaft, and then you have the bearing mounted over there. And after the bearing, okay, there is a after the bearing there is some sort of a uh, yeah, there is an oil seal, and then after that the alternator design comes into play. In the middle, using another key, you rotate the rotor of the alternator. Okay, so mm, anyhow, you have all those things, and then on the other side there is a spherical roller bearing which is used. Okay, so these are spherical rollers. These are spherical rollers over here. So there is a spherical roller bearing on the other side. Okay, so if I have to very quickly point out the machine elements in this particular problem, okay, which need analysis, you have the pin, you have the bushing, uh, you have brackets and welds. Okay, so there are welds, you have the pulley, you have to make sure nothing in the pulley breaks, you have the key, you have the shaft, bearings. Okay, so we need to make sure that none of these elements fail, or they have the desired life within the system. Okay, now so yeah, anyhow, so these are the major components. See, one of the habits that you need to develop if you are interested in machine design is you need to get a hang of the size and weight of the components that you are dealing with. Okay, you need to know how things look in terms of size and how much do they weigh. Okay, now weight is a very important factor in most of the machine design in any analysis you do. What are the reasons why weight becomes very important in any design analysis?
Sir, it affects the moment of inertia.
So fine, so it plays a role in dynamics of the system, so mass, moment of inertia, fine. Why is weight important? Weight is super important. Okay, now let us say you are designing the chassis or the body of a car or body of a two-wheeler. Okay, all of you know that Ather has come up with some aluminum frame for its electric two-wheeler. Okay, while majority of the chassis for the vehicles is made out of steel. So let us say, just for argument's sake, that that chassis weighs about 50 kgs. Okay, now instead of 50 kgs, sorry, chassis won't weigh 50 kgs, let us say it weighs 20 kgs. Now instead of 20 kgs, so it's very important to know whether it should be 20, it can be 16, or it should be 25. So Why is the weight of components so very important?
Sir, it will affect the power requirement also.
For many reasons. Okay, so weight is important.
Sir, it will also have some internal stresses due to the weight near bearings and screws.
So weight is important for a variety of reasons. One is like material and processing costs. Okay, so if for Aether, if I can go from 20 kgs to 16 kgs, I will be saving on material cost straight away by about 800 to 1000 rupees minimum. Okay, per vehicle I'll be saving straight away on the material itself. Typically processing cost scales with the material cost. Okay, so I'll be also saving on the processing cost, so I'll have a huge savings in terms of what it will cost me to make the component. Okay, second I will have efficiency is linked to weight. Efficiency is linked to weight. This is very much true in the case of automobiles. Okay, so smaller the weight of the system, the more efficient it is. So the more efficient it is. Okay, so you also have that advantage. And then one very non-trivial observation is that inertial forces inertial forces scale with weight. Scale with weight. Okay, so in the case of permanent magnet alternator, so let us say initially we were thinking, why can't it be just directly welded to the bracket be welded to the frame or rigidly fixed to the frame. Okay, so let us say it is rigidly fixed to the frame. The if I make a free body diagram for the bracket on which the PMA is supported, okay, the forces which will be acting on these brackets, what will they scale with? Or the forces which the welds will have to support, what will they scale with? Or what will they depend on? They will depend on weight, right? So you have the gravitational force that is anyhow there, which is equal to m times g. Okay, but much more than the gravitational force, particularly for automobiles, can be the inertial forces. Okay, on trains particularly, when you're looking at wheel sets and bogie, the peak acceleration momentarily can reach as much as 5g for the case of bogie, and it can reach as much as 50 to 100g for the case of wheel set. Okay, so the inertial forces, they scale directly with the weight of the component, and the lower the weight, lower will be the forces which, for example, the welds or the structure will have to support. So for all these reasons, you need to pay a very means you need to pay close attention to the weight of the components, and wherever possible you need to shave off the weight. And one of the important purposes of any design analysis, so one purpose is to make sure that whatever design has been provided, it is fail safe, means it is safe at least for the life which has been specified. Another very important purpose is to see whether weight can be reduced anywhere without reducing the structural integrity of the system. Okay, so any case, so in this case, so what is the weight of this permanent magnet alternator as per this design? The weight is close to half a ton. Okay, it is about 500 kgs. Is this high or low? What's your reference?
Sir, high.
It's
Sir,
high.
low.
With reference to what?
Sir, for a train, it's quite low.
Yes, so compared to a train weight, yes. So uh, an empty train, okay, would be weighing about 50 tons. So fine. So with respect to the train weight, this is about yeah, about 1% of its weight. So, but would you be comparing with the train weight if you want to know whether a motor weight is okay or not? You should be
No, sir.
comparing with other motors, right? Or other generators. So uh, I would say this is slightly on the higher side. So what is the today, if you want to compare for electric motors, okay, what is the gold standard, or like what's the best design out there? What would you be looking at?
Electric vehicles.
You can be looking at electric vehicles. Actually, they are making massive progress in the motor design, in the power electronics design, in the electric vehicle segment. So you take something like Tesla motors, they generate enormous amount of power, close to some 200 kilowatt odd, in a very small amount of, with a very small amount of motor weight, somewhere around 50 kg odd. Okay, so they have very high power density motors. It's not apple to apple comparison, because the RPMs at which they operate and RPM over here are very different, but still there is a lot of scope for improvement over here. What is taking up most of the weight in the design?
Sir, the shell and
So the shell is taking up most of the weight, and also
Stator.
the pulleys.
Step.
Okay, so the pulleys are also means yeah, the stator stamping and the pulleys, these are taking up, means these are contributing the most to the weight. And actually shell is one of those places where you can do weight optimization. Okay, it's a simple structural component, and you can always see whether through a choice of material, or you can see what all ways you can reduce the weight over there. Okay, so anyhow, now so at the end of the day, what the company needs to provide, okay, to a manufacturer are the manufacturing drawings for the components. And over here, just for indication, I have shown you the shaft drawing. It looks quite complex because it does have quite a few geometric features. Okay, so now in this particular case, if I sort of zoom in, so means because it has so many different geometric features, the drawing also looks a little bit complicated. But what are all the features you can see? You can see the thread. Okay, you have a bunch of fillets. So you have a tapered surface. Okay, again a fillet, a undercut, an undercut, key, key slot. Okay, so fine. So you have all these different geometric features on the shaft. Okay, now fine. So actually, I was doing the analysis of analysis of machine elements for a company called Signatron. So the drawings are all from Signatron, but right. So I was looking at they are a power electronics company, and they work for railways. And railways had placed some new product requirement, for which Signatron was doing R&D and making some prototypes as per their requirement. They had come to me to do the analysis of the mechanical components or the machine elements within the system, to make sure that everything is okay, and make some recommendations, whether it is with regards to thinning of components to reduce the weight, or to increase the rating of the components to make sure that none of them fail. So I will not get into the details of the analysis, but the point is that whatever analysis I have done in for this particular project, all of these concepts, most of the concepts are covered in this particular course. Okay, so now one important point to note is that in the machine element, so when you take the machine elements, okay, so some of them are selected. Okay, selected, some of them are selected. So if you are talking about bearings, belts, bolts, these are selected. What do you understand by selected? Selected from where?
Shop, sir.
Yeah, so selected from a product catalog. Okay, or so every manufacturer, so let's say there is a bearings manufacturer, they would have a wide variety of bearings which they make, and under each variety, let us say cylindrical roller bearings, again they would have a lot of different models, and for each model they would be providing some product specification. Okay, so by looking at these product specifications, you have to select the appropriate component for your application. Okay, so some elements will have to be selected. So in the case of belts, they were using this particular model of the belts. So the company name was Fenner, the product name was Fenner Powertrain. So this is the nomenclature, some SPC hyphen PT 3155 LP. So this basically is the pitch length of the belt. Pitch length of the belt. So 3155 mm is the pitch length of the belt. So I was considering this particular belt. So some components will have to be selected and some components will have to be designed from scratch. Some will have to be designed from scratch. So can you name a machine component which will have to be designed from scratch? So things like shafts, bushings, keys, structure. Okay, so these will have to be designed from scratch. So in the case of belts, I was looking at two different failure modes. One was wear and another was fracture of the belt. Okay, and what you will be providing or what you will be getting as output of all of your analysis would be the safety factor. Okay, so for this particular failure mode, what is the safety factor? And here are some remarks. So basically, uh, what are you designing for? So uh, there is a certain design power. So even though the alternator is only of 30 kilowatt nominal power rating, okay, so because of some spikes within the system and all that, the design power requirement is actually 51 kilowatt. And then there is some efficiency within the system, and for the belts, there is something called service factor which we need to take into account. So in the end, uh, looking at all of these considerations, power per belt chosen is 5.7 kilowatt, and based on this, this is the power, sorry, the safety factor that I get is 1.33. So the bottom line is that we would be able to, for these choice of belts, we would be able to safely transmit whatever power is required in this particular application with this much of safety factor. Okay, and then fracture. So what is fracture in the case of belts? What will cause the fracture of the belt?
Tension.
Tension. So if you exceed the maximum allowable tension within the belt, then you can have a fracture of the belt. So anyhow, some maximum allowable tension in the belt is provided, and then within the application we assume some maximum inertial loading which can happen, so 5g vertical and 3g longitudinal acceleration. And for that, based on design analysis, I find that the maximum allowable tension is this much. So fine. So I get the safety factor to be this, and I also analyze and I find that maximum required friction coefficient is 0.6, but as per manufacturer the belt pulley interface can provide a friction coefficient of 1.2. Okay.
So,
Yeah.
can you explain how a fracture occurs in a belt? Like tears are understandable, like the belt stretches, etc. But how does fracture occur in a belt?
See, the belts consist of it's not a homogeneous material. So if you look at belt cross section, okay, so you would the matrix which is holding everything together is some synthetic rubber, but then you have some sort of reinforcing cloth. In some cases you also have some metal wires which are running through the whole thing. So typically what happens is that one of these elements fails. So let us say there is some reinforcing cloth, you have used some sort of a glass fiber or polyester cloth or something, okay. Now this is a relatively brittle material and it would fail at certain level of force or stress within the member. So the failure would initiate from over there. Once that fails, then there is a stress concentration and the crack propagates, finally resulting in failure of the belt. But the bottom line is that the belts which we would be using, they do not it's not a ductile failure, meaning it would not deform by a great amount before it fractures. uh, so the next thing that I looked at was this coil spring. Okay, so what can go wrong in a coil spring? One of the things we are worried about when we deal with springs is some permanent yielding. Okay, so permanent shape change in the spring. So meaning you compress it, but when you release it, it will not come back to the initial position. Okay, and what is the most you can compress a coil spring? That is up till the full compression at its solid length, meaning the coils are touching one another and they cannot be pushed any further down. Okay, so fine. So for some assumed material with some properties and some spring and the spring geometry which has been given, I find that there is a safety factor of 1.33. There will not be any permanent shape change in the springs. And this way for every machine component, I assume, means I need to say what is the failure mode, and then I know the what is the material which is being used, what are the properties of the material, what are the reasons, means what is causing the failure, and based on all of this I find out the safety factor. So I do this for the key, for the spokes, for the alternator shaft. Okay, for the alternator shaft, for the shaft it's a rotating member, so we have to worry about yielding from jerks, and we also have to worry about fatigue failure. And typically the safety factor is lowest for the fatigue. Okay, for static failure typically the safety factor is much higher. Okay, do all of this. And then for the bearings, so as I was saying, for the bearings the life is specified in terms of millions of kilometers. Okay, for the bearings also you have rotating elements within the bearing, so you have to worry about the fatigue life as well as the static failure. So once again for each of them I get the numbers, and the minimum specified by RDSO was 16 million kilometers. So it's fine. It's fine. So there are two bearings in this application. One was a cylindrical roller bearing, another was a spherical roller bearing. So this is the cylindrical and this is the spherical roller bearing. These are the specific model numbers. So it's fine. And then bushing. Bushings are typically made out of nylon. They provide good lubrication at reasonably good strength. So in this case, I am assuming the nylon to be some specific grade with some specific tensile and yield properties, and based on that I get the safety factor. So what do you see, like in all of this analysis, when we are doing the design analysis, what are the two most important aspects, or name some important aspects?
Safety factor.
That's what we need to get in the end. See, you cannot say that, okay, you have a safety factor of 1.5 or safety factor of 2. That by itself means nothing. You need to specify the part. You need to specify the part, the loads which are acting on the part, the material that the part is made of, and the material properties that you are considering. And yeah, so only after you specify all these things, and you specify the failure condition also, what are you considering as failure? Okay, so only after you specify all these information does safety factor make sense. And this is also going to give you a protective cover. Okay, so for example, let us say, let's go to this shaft. Okay, now I am saying that the shaft will have to be hardened to this particular hardness value, and I would like an yield strength of at least 860 MPa. And with this yield strength, I'm going to get this safety factor. Okay. Now let us say somebody forgets to do the hardening of their shaft. Okay. Then automatically the safety factor will be very low, and probably it will fail from yielding if they do not harden the shaft, because without hardening they may end up with a yield strength of somewhere around 200 MPa. Okay, 200 to 220 MPa, which is 4 times smaller than what they would have if they were to harden the shaft. Okay, so the safety factor that you are providing is valid only when you have performed the hardening. So that is the reason. And also remember, I am doing analysis for 5G jerk. Okay, imagine there is an accident, and during the accident it is subjected to 20G. Okay, 20G acceleration, then the component will fail under that condition. Okay, so the failure, the safety factor that you are generating, it is for some particular machine component made without any defects, from a certain material, with certain properties, subjected to a certain loading. Okay, so if any of these things are violated, then your result cannot be relied upon. Okay, and for the case of the shaft and for the body, I was using finite element analysis in order to find out what are the maximum stresses and what are the deflections within the system. So normally when we think of failure, we always think in terms of stress, permanent shape change, fatigue failure, and all of that. But deflections are equally important. Okay, so you cannot have things deforming or deflecting by any major way whenever they are subjected to loading. So in this application, in the worst case, I found that the maximum deflection was about 0.16 millimeters for the case of the body, and about 0.45 millimeters for the case of the shaft. For the case of the shaft. Okay, so that's it. This is what I wanted to cover. So what do I want you to remember from all of this? So anytime you're doing a machine design, once the technical specifications are provided to you, you start by figuring out how to achieve the desired kinematics, how to achieve the desired motion of items within the system. Then you use free body diagrams to find out what are the forces and moments which are acting on each of the components. Then you have to propose some part drawings for things which have to be designed from scratch, and you select some items for whatever has to be selected. So you need a starting point which you are proposing, and proposition normally happens from experience as to what is it that you should uh, how things should look, what material they have to be made of, and all of that. And once you have a proposed design for each of the components which are being designed from scratch, and you have made some selections for things you will be buying off the shelf, then you start to do your design analysis, okay, which is basically, you know, the forces, moments and stuff, and you assume some failure modes and see whether your components will survive those forces and moments or not. If you have over designed, you have to thin the components to sort of make sure that you have the right safety factor without things being too overweight. If some stresses are being too high in some particular region, then you need to think of ways to reduce them, okay. So this is it really. Now the course is challenging because there are so many different concepts that you're going to learn, but one great thing about this course is it will get you very close to reality, meaning whatever you learn here, if at all you get into the core field and if you are associated with any sort of a product design, things you learn here will be really helpful and they can be directly applied. And as I have told you, the project which I just described to you, this was something I have done about a year back. um, Whatever I have done, most of the things are covered in the course, okay, except for this FEA part, finite element analysis part, everything else is covered in the course, okay. All right, so any questions?
Sir,
Yeah.
when you were talking about that wheel set, you said that trains do not allow for like independent motion of wheels. So when the
Yes.
train is curving, doesn't that generate a lot of stress, and like over time it could like cause fatigue and like fear?
Yeah, just a second. I'll answer that question. Just a second. All right. So I have. So the way I'm going to do things in the classes in this particular course is the last 10 minutes odd. I'm going to ask you to answer some questions in a form on Teams on the content I have covered on that particular day. There are two reasons for me doing this. One, through this particular quiz, I would like to reinforce the concepts I want you to remember. Okay. So this is more to highlight what is it that was covered and what is it that you should remember from what was covered in the class. And second thing is this will also help me keep a record of who has been attending the classes. Okay, I'm not going to take attendance separately. For me, taking attendance online for 250 students is not doesn't make any sense. So and this is anyhow the format which is now being followed internationally. You look at Coursera courses, Udemy courses, there are some few questions at the end of the class. So all right, so the quiz has been posted. uh, I won't directly be sort of taking the marks and then giving you marks. It's more for you will be sort of the fact that you have submitted is mostly sufficient for me. Okay, so please be honest when you are answering the questions. This is mostly for your learning. Okay, so go ahead and answer those questions, and I will also answer your last question. So during curving,
So can we start? So can we start
go
the
ahead, go
quiz?
ahead, go ahead, go ahead and start the quiz. Yeah. So during curving, so the wheel sets, I'm not sure if I can. Right. So if you look at the wheels, they are not cylindrical, but they are tapered. Okay. So there is a certain incline. So if you look at the wheel profile looks like this. Okay. So what happens is that for the wheel which is on the outer curve, the contact point will be here. So the radius of the wheel will be higher. And so let us say this is on the outer side, and on the inner side the contact point will be over here and the radius will be smaller. Okay, so this is our outer, our inner, And because of this, even though the wheels are rotating at the same rpm, the outer wheel will cover more distance as compared to the inner wheel. So so it is the wheel profile which allows you which helps you with self steering in the case of railways.
Okay, sir, got it.
Just a minute.